So I recently bought this big induction heater. It says it's 1,000 watts if you run it on 48 volts, 20 amps. I don't have a power supply that can do that. I bought it and I was going to run it on a 12 volt power supply, but it's not very good on 12 volts. So I want to make a 48 volt power supply. So I need something to turn the 120 volt wall power into the 48 volts I need. So I will be using a big transformer. 48 volts. I've got this giant transformer that can help. It has a bunch of pins, and there are a few that can output 48 volts. They all output different voltages, and it's pretty heavy. This is the Onkyo high current power supply transformer that I found inside of an AV receiver. But we can't just put this into the outlet and then put it into our induction heater. Our induction heater requires DC. So that's why I bought this ginormous full bridge rectifier. This is the MDQ 100 amp 1600 volts. That's like 160,000 watts. And I will be turning the AC into DC. But it doesn't work by itself. We need capacitors to smooth it out. So that's why I got these two big 10,000 microfarad 69 volts capacitors, put them in parallel, and that should smooth it out pretty well. And I also got this from the same AV receiver as this transformer. Let's get building. So I soldered the green wire to 48 volts, and I soldered the black wire to common ground of this transformer. So this bridge rectifier has two AC inputs and two DC outputs. So I'm just going to plug the AC into the right one. It doesn't really matter which one you plug it into because it's AC, but the DC it does matter because DC is polarized. Now let's add our capacitors. I'll get some more wire. I've got more wires. I'm just going to put white into positive and the blue one into negative. Now, the reason I chose this bridge rectifier is this power supply I need to pull so many amps from to run that induction heater. And I'm pretty sure the transformer can handle it. But if you just put like 4 1N4007 diodes, that's like a really common rectifier diode. If you just 4 of those in a bridge rectifier configuration, they probably wouldn't stand a chance. This is probably best suited for that. There. Now we can connect it to our capacitors. I'm going to connect the white wire to the positive of the capacitors and the blue wire to the negative of the capacitors. If we get that mixed up, then the capacitors would probably blow up because these are electrolytic capacitors, and electrolytic capacitors are polarized. So we need to get the polarity right. So we made some big sparks with a screwdriver. I'm going to try it with this rebar. Here we go. Ah, that was crazy. Look at the rebar. Got some big scorch marks on it. I probably shouldn't do that to the capacitors. at such a high voltage. I'll just discharge the rest. I probably shouldn't do this anymore. Let's measure the output voltage with my all-new Roshoi 9808 Plus multimeter. China comes up with some weird names, but don't let the names deceive you. This is a great multimeter. They're not sponsoring this video in any way. I just think this is a great multimeter. And I'm going to be measuring the output voltage of this power supply. I'll have to do that rebar thing again to discharge it. Here we go. What does it say? Almost 60 volts. That's crazy. Okay, now I'm going to discharge those insane capacitors, the rebar again. Here goes nothing. More scorch marks. Okay, 60 volts. I'm going to look at the video replay to just make sure. Yeah, it was actually 60 volts. That's too much for my induction heater, so I'll have to use one of the lower voltage pins on the transformer. Made some pretty big sparks. See you next time. Here's a big freeze frame of the sparks. See you next time. Bye.